So this is example 11.3.2 and it's the graphical derivation of the Newton-Raphson formula using this diagram. It is something that you need to be able to do, but it also just shows you where it has come from in terms of the formula. So that's what we're going to be looking at. So we are starting off at this point here. So that's my starting point. And if this is the function, so the blue function is y equals f of x, then this coordinate is xn, so the x coordinate. The y coordinate will be f of xn. Okay. So what we're going to look at is the gradient of the tangent at that point xn, f of xn, which would just be differentiate that and substitute your x value in. So the gradient of the tangent at that point is just that. If I then wanted to write down the equation of the tangent, I know the gradient, I know a point on the line, so just using exactly the same process as what we've used all the way through A level. So we've got y minus y1 is equal to m x minus x1. So I am using that as the gradient and that as the coordinate. Okay. Focusing on this point here, so we know that that has coordinate xn plus 1 and the y coordinate there is 0. So where does the tangent cross the x-axis? Which is the whole process. So you find a tangent, you find the x value where it crosses the x-axis, and then you repeat. So that's what Newton-Raphson's doing. So if we are looking where we cross the x-axis, y is equal to 0. So I've got 0 minus f of xn is equal to f dashed of xn. The x coordinate that I'm looking for, or substituting in at that point, is n plus 1. And I've got xn there from the formula. So rearranging that, if I divide through, what's that minus sign? By that derivative, I'm trying to make xn plus 1 the subject, because that is the coordinate that I'm looking for. That's the whole point, finding out where that tangent crosses the x-axis. I can then add xn across. And there it is. So that is how you derive the Newton-Raphson formula from